Hi, this is John here, and today I want to share with you a pretty advanced method for speed. And in this section, I'm going to show you there are two types of methods, and they are called direct proportion as well as indirect proportion. What do you mean by that? Okay, for example, if you double your speed, the time taken to travel will be half. Or if you slow down your speed by half, the time taken by you will double. Yeah, so this is actually something that we learned in Sec 1, but interestingly, it can be applied in primary school as well, and some of the children that who I have talked to have also learned this in school, and I think that it's really fast. And in fact, many of the high A's and the A-star performers or students are actually using it. Yeah, so I want to take this opportunity to share with you. Okay, yeah, at the same time, it's something that you could have heard before, inverse proportion. Yeah, but in primary school, we want to use simpler words like indirect proportion to replace inverse proportion, and the other one will be the direct proportion. Yeah. Okay. So let me use this very simple table. Okay. So remember we were saying that if your speed is double, your time will be half. Okay. So if it's triple, your time taken will be 1/3. Okay, so you can see the table above. So when you are comparing the relationship between speed and time, so in this case, under same distance, that means the distance covered is the same. Let's say vehicle A and vehicle B. Yeah, so in this kind of question, you need to see two vehicles or two persons. So the story about the speed question is always about comparing between two things. So when the speed is 2u for A and 3u for B, and because of this indirect or inverse proportion, the numbers should swap. Yeah, so top ratio for speed will be 2:3, and the time ratio will be 3:2, just because of this indirect or inverse proportion. Okay. On the other side of the table, you can see at the same time. Yeah, when the time is constant here. So when your speed is doubled, your distance traveled will be doubled as well. And if your speed is tripled, your distance will be tripled as well, because you can travel more and take a longer route because your speed has increased. Yeah. So this is what we call indirect proportion. Indirect proportion. Yeah. So again, vehicle A and B. So we have 2:3 ratio for speed. Distance wise will be 2:3 as well. So what you can take note is that this is a direct proportion, so meaning that if the top is 2:3, bottom will be 2:3 as well. And for the same distance, when you compare speed and time, the numbers swap. Okay, like if this is 2:3, this will be 3:2. If this is 3:4, it will be 4:3. If this is 4:5, this will be 5:4. So this is what I meant. Okay, so this is indirect proportion. Okay, so we'll move on to an actual question to teach you how to apply it. Alright, so in this question, we are talking about how do you apply the direct proportion. So first thing in the question, we are going to change to a pen. Okay, so let me use blue. Okay, so Zen and Tammy both left home and cycled to the same supermarket at 9 a.m. And you can see that in this case, this is the first clue to know that they are actually traveling the same distance. At 11 a.m., when Zen reached the supermarket, he realized he arrived an hour before his sister. So if the distance from their home to the supermarket was 60 km, and for the facts that I underline this is because I want to tell you that it's actually same distance, okay, same distance. What was the difference in their speed? Okay, so in this case, we are going to solve using the indirect proportion because it's same distance. And if you're not very sure, you just rewind to the front part, whereby you notice that if you're talking about same distance, the remaining, okay, remember your DST triangle, right? So your DST. So with same distance, you only have speed and time. Okay, so your speed and time. So let's see if there's any comparison. Okay, so both left home. Okay, and you can see that right here, 9 to 11. So actually Zen actually took 3 hours, and then before his sister. Okay, so before his sister. So meaning that, okay, again my apologies, this should be 11 minus 9 because from here to here is only 2 hours, so 2 hours. So he arrived an hour before his sister, so Tammy actually took 3 hours. So remember the indirect proportion. So we have 3 is to 2 because here is 2 is to 3. The top one should be 3 is to 2. So quickly we put parts at the top and units at the bottom to remind you that they are different. Yeah. So having said this, we know that from here to here is 1 hour, right? It's because of the difference, because of this sentence. So 1U is actually 1 hour, and then they want to know the difference in the speed. So what we can do here is we can actually find Z speed, okay, Z speed, which is 60, which you have it here. And to find speed, again, you can use the triangle d over time. So this is 2 hours is 30 km per hour. So meaning that with reference to this, 3p is equals to 30 km per hour. So you want to find the difference, you just need to find 1p. There's no need to find 2p and then you minus off. Always go for faster way because time is really a rare resource in exam. Yeah, so you better work fast. So 1p is equals to 10 km per hour. Alright, in this question, you want to read by yourself first while I change the pen. Okay, so in this case, every day Mr. Lim drives his son to school. So from home at an average speed of 60 km per hour, and one day they left home 10 minutes later than usual. So Mr. Lim has to increase his driving speed by 20 km per hour so that his son can reach school on time. What is the distance between his home and school? So with this, we know that there's some form of relationship between the two speed. So we know that also in this case is under same distance. Okay, same distance. So in scenario 1, okay, in scenario 1, before Mr. Lim drove faster, and in scenario 2 is when Mr. Lim drove even faster. Yeah. So scenario 1, your speed is actually 60, and then because in scenario 2 it's 20 km per hour faster, so it's 80. And again, always work with small numbers, so you have 3:4, and so you have 3U/4U. Okay. So what about the time? Remember the idea of indirect proportion, the numbers swap, so we have 4 parts to 3 parts. Okay, so in this case, what do we do next? You'll notice that the other thing is that it's given will be the difference. Yeah, so this is 1 part equals to 10 minutes. Okay, and then the distance between his home and the school, and you know that either you do scene 1 or scene 2, your answer will be the same. So for me, I will always go to the first one. Yeah, because it's the first one to be used. So don't spend too much time to decide which one to use, because your answer should be the same. So in this case, 4 parts wise, you know that it's 40 minutes because it's 4 times 10, and because it's talking about hour, so you have to change to hour. Okay, so the distance here will be 60 times 4 parts, which is 2/3 hour. So we have 60 times 2/3, which is, if you do cancellation to speed up your calculation, so this is 40 km. Alright, Helen and Tammy were running from point A to point B, which was 90 km apart. So Helen started 30 minutes later but arrived 1 hour earlier than Tammy. Okay, I think the key here is you want to look at comparison sentence, and then this will give you a very big clue to know where to start to form your relationship. Because once you are able to form that relationship or ratio, you can actually invert it or inverse it, or do a direct proportion depending on what other values you have. Yeah, so let's read on. If Helen's running speed was 30 km per hour, what was Tammy's running speed? Yeah, so very quickly, again, I will label this under same distance. So we have H and T, and then the one that I can start off first is the time relationship. So we have 3U is to 9/2. Alright, so you may ask me why 3U. So let me show you how. So 90, 30. So with this, for Helen, when you have speed, you have 90/30, which is 3 hours. Okay, so that's why you have 3 hours here. And Helen actually started 30 minutes later. So for Helen's time, 3 plus half plus 1. Yeah. So you have 4.5 hours. Okay, because Helen actually started half an hour later, that means Tammy actually took half an hour more, right? And then arrived 1 hour earlier than Tammy, so Tammy actually took 1 hour more. So you have 4.5. Yeah, so again, in fraction, this is actually 9/2 hours. So again, the focus here is to, once you have this relationship, you want to quickly put them as units. Yeah, and then your speed will be 9 over 2 is to 3. Why? Because of indirect proportion. And you know that the other value that you have is actually 30. So this is actually 30 km per hour. So to solve it, you want to take 9 over 2, P equals to 30, and 1P will be 30 divided by 9 over 2, which is 30 times 2 over 9. Okay, so let's keep it first, because you know that 30 divided by 9, you get some funny numbers. Yeah, so let's see what we can do. What do they want? They want Temi speed. So Temi speed will be 3P. So we take 3P equals to 30 times 2 over 9, and then times 3. So with this, we can actually do cancellation, and you get a very nice number, which is 20 km per hour. Okay, so in this question, a lorry started traveling on a highway at 2 p.m. at an average speed of 60 km per hour, and a van started traveling on the same highway at 4 p.m. If the van took 3 hours to overtake the lorry, what is the average speed? Yeah, so again, when they meet or when they overtake, right? When the van overtake, we are talking about traveling the same distance here. Okay, same distance. So we have L and V, and the time will be, okay, so let's see what happens. Okay, so for the lorry already traveling at from 2 to 4, yeah, which is 2 hours here, and then that's when the van actually started to move. Yeah, so you need to add another 3 hours. So for the lorry, it's already traveled for 3 hours, and the van itself only took for the lorry, actually it has been traveling for 2 hours, and you need to add another additional 3 hours. Yeah, then for the van, you need to just put 3, because 3 hours is the one that is the total time that the van has traveled. Yeah, and you must also take note that the van actually traveled later. Okay, so in this case, we have 5u is to 4u. Okay, so for speed wise, you know that is indirect proportion, so we have 3 parts to 5 parts. Okay, so what else can we do? Can you see the 60 km per hour? So in this case, 3 parts is actually 60 km per hour, and 1 part is 20. And what is the average speed of the van? So you actually have 5 parts, which is 100 km per hour. Yeah, so because you're just using here. Okay, hope this helped. Alright, so at 11 a.m. Elaine traveled from town H to G, and which was 315 km apart. At the same time, Joanne traveled from G to H at a speed of 60 km per hour. At what time did they pass each other if Elaine's speed was 40 km per hour? Okay, so in this case, I realized that there is already a comparison. Yeah, so I quickly use it. So E is to J, so we have 45 is to 60. Simplest form will be 3u is to 4u. Yeah, so divided by 15. Okay, so distance wise will be 4 parts to 3 parts, indirect proportion. Okay, so in this case, a total of 315 km. So that means that when they pass each other and they are traveling towards each other, they will have covered both. Yeah, so we are talking about 7 parts is equals to 315, and 1 part is equals to 45. Okay, so at what time did they pass each other? So we are looking at just using 1. of them, and let's use E. Okay, so E's time taken will be 3. Okay, so let's see, divided by 45. So, okay, not sure if you realize that there's a mistake here, yeah? So I think it's a very good chance for us to take notes. With greater speed, you can cover more distance. So actually, this is direct proportion, okay? So take notes, because sometimes when we do too fast, we tend to make this kind of mistake. Yeah, so in this case, it's a direct proportion, so 3:4, 3:4 as well. So we have 3 parts divided by 45, because if you use the DST, time will be distance over time. Sorry, distance over speed. Okay, so in this case, we have 3 times 45 divided by 45. Okay, so cancellation for both will be 3 hours, and then you have the time taken will be 3 hours plus 11 a.m., which is 2 p.m. And this is the answer. Okay, in this question, it's a bit different, so I really need you to listen carefully. Yeah, I throw in this question because it's something that is a bit different, and not all the times we can use direct proportion. And I want to share with you why sometimes it's so easy to detect that you cannot use either direct or indirect proportion. Okay, so the distance between town A and B was 360 km. A motorcyclist began traveling from town A to B at 12 p.m. and at the same time, a car was traveling from town B to A. The car traveled at a speed of 10 km faster than the motorcyclist. So this is a clue that probably there can be some sort of comparison. Yeah, both vehicles pass by each other at 4 p.m. So you have A and B. Okay, let's not look at A and B first. Let's ask ourselves whether we can form some ratio. Yeah, though you do have a difference here, yeah, but if you scan through the whole question again, you realize that it's pretty hard to have nice numbers like, or you're given the speed of the car and then the speed of the motorcyclist, or at least you can use this relationship, this difference, to find the speed of the other vehicle. Yeah, so no matter how you scan, there is nothing you can do. Yeah, so not all the time you can use direct or indirect proportion and be okay with it. Okay, so I want to share with you a method here, which is, because in 1 hour the car is actually traveling 10 km faster. Yeah, so from 12 to 4 p.m. Okay, so in 1 hour, it's already 10 km more, right? So 2 hours you have 20 km, and then 4 hours you have 40 km more. Yeah, 40 km more. So that means the car is always traveling, has traveled 40 km more than the motorcyclist. Alright, so having said this, let's look at the distance that we have. So if you have C and M, and you know that C has traveled more, which is 40 km more, and the total is 360 km. So if you take this away, you know that this 2U is actually 320 and 1U is 160. Okay, 160 km. Alright, so with this, you also Okay, let's see with a DST triangle of the motorcyclist. Okay, so this is DST, and then I need to find the speed, right? So distance-wise, I have 160 km. So next, you know that you need to find this one. So what can we do? It's actually from where? So from 12 p.m. to 4 p.m. is actually 4 hours here. Yeah. So you know that to find the speed of the motorcyclist is 160 over 4, which is 40 km per hour. Okay, so this is answer for part A. What about part B? Yeah. Okay, so before I move on, this is how I actually make use of triangles to tell me what to do next. Okay, so the car wise, you also need a DST. So DST for car, and the time taken will be a question mark. Yeah. Distance wise is the same, right? Because it's still 360, and speed is 40 plus 10. Yeah, because 40 plus 10 here. So you have time taken, which is 360 divided by 50, which is 7.2 hour, and you have 7 hour and 12 minutes. Alright, so the time taken will be, to end off, is actually 7 hours and 12 minutes plus 12 p.m. is actually 7.1212. 7.1212 p.m.